was a question 8. Again, I've lost the a little bit of this because I made it a bit bigger. You're told that the current shown is used to charge a capacitor. The graph shows the charge stored in the capacitor while it is being charged. And you see charge versus time. Now, the next bit of the question, I'll just put this down here, says on the same axis, sketch as accurately as you can a graph of current versus time, current against time. Label the current axis with an appropriate scale. So we're going to have a current axis, so we'll put the current axis over on that right hand side here. Now, we know that Q is equal to IT. We've got Q versus T, therefore I is Q over T. But to be really accurate about this, instead of just taking values of Q and dividing them by T, you must take the gradient of each part of the graph. So you have to draw a couple of tangents here. I'm going to draw them lightly with just an ordinary colour pen, a green pen here. Just you see, it does give you different values than just dividing Q divided by T. If you took these values here, you will get different values. It's far more accurate to do a tangent. So if we do a wee tangent for the first bit here, and we're going through the origin here, so roughly there, well, that will give us your first tangent there, roughly. It's quite a difficult thing to do, but provided you have shown fairly accurately. So your first tangent there at T is equal to 0. You can't see that, so I'll just do it in a different colour. When T is equal to 0, then the tangent is equal to, it's roughly 10 divided by 0.3 there, 0.3 seconds there. And the 10 is microcoulombs, of course, so it's 10 divided by 0.3. And that gives you an answer of roughly 33.3. Okay, now if you do this at a whole lot of other places, you come up with values. I did it at T equals 0.4, which is over here. It's this value here. And when I did it there, I got an answer of, when T equals 0.4, I got an answer of I is equal to 27.4. I then did it for T is equal to 1.2. And I got an answer of I is equal to 12.5. I also did it at T is equal to 2.2. I got an answer of 4. And the last one here that I'm going to put in, T is equal to 3.2 and I is equal to 0.1. So your scale on the right hand side of the graph goes up to 33.3 for your first value there, roughly, about 33.3. And so if you're going to plot that, you're going up to about here. There's 33 there. Okay, so your first value of T is equal to 0 is roughly about 33.3, about there. The next value I've got here is T is equal to 0.4, which gives you 27.4. 27's there, 0.4. The next one, T is equal to 1.2, and that's at 12.5, which is about there. The next one, T is equal to 2.2, I is 4. And the last one, T is equal to 3.2 and I is 0.1. And so there's your graph, go down roughly, something like that. The last part of the question is a very, very simple question. It says the power supply is 3 volts. Calculate the resistance of the charging circuit. So all you're doing there is V is equal to IR. We now know that our initial current, for my calculation, was 33.3 microamps. And therefore R is equal to V over I, which is 3 over 33.3 microamps. You have to be very careful not to forget about the micro. So that's by 10 to the minus 6. So that gives you an answer of 10 to the minus 6, gives you an answer of 90,090 ohms. Or it's really 90.09 kilo ohms. So the thing that would catch you out there possibly is your micro. Just be really careful about that. You would get an error carried forward. Whatever value you had up on your graph as your initial current, you would get that error carried forward. And that's the end of your capacitor test. Thank you.